In the previous lab, we downloaded the file, the JSON file, from the web page, and we loaded it into R. We explored the data, the traffic data, and we also explored the density plots. In this lab, we will continue with our exploration of the data. Now we will plot traffic at start as on the x-axis and traffic count on the y-axis. So the data looks like this. There are only 2 dates on which the traffic data has been collected, as we can see. Then let's plot the traffic. Let's plot box plot. So it's a box plot we are plotting. Box plot of traffic at lane number and traffic at lane number, but is actually not reading the traffic at lane number. So let's remove that. So box plot of square root of traffic at square root of traffic count value, and it's rounded to 2 decimal place, and the color equal will say factor the class weight. So the class weight are of values heavy and light. We will factor that, and we'll take the n levels, and we'll take the rainbow color of that. Now just show you what happens. So factor traffic at class weight gives us this. Then we take the n levels of this. And there are two levels. And when we do rainbow, these 2 levels, then we get 2 colors. So color, that will be 2 colors. Then define legend entries. So 1, 2, 2, 3. So we have this. This, and this. And define legend entries and colors. Let legend text equal levels of factor of class weight. So levels of factor. So let's do that. And that will be heavy and light. So levels of factor of class weight is heavy and light. Then let legend colors equal rainbow of n levels of factor of traffic at class weight. So these are the 2 colors. Add legend manually. Legend on the top right, comma, legend text, which are the levels heavy and light, comma, fill equal legend colors, so the 2 colors that we found, comma, title equal color, so the title of the legend is color. And when we run that, we get this. So we get um, uh, heavy vehicles, and these are the traffic counts. What we if we subset the light and heavy vehicles? So let's do a table of the class weight, and that gives 783 vehicles are heavy and 1217 vehicles are light. Then table, so let temp equal, we subset from the traffic data, we subset class weight equal light. So when we run that, when we print the first few lines of the temp data frame, we you can see class weight equal light. Then we import the library plotly. Then we plot the interactive box plot. So let p equal plot underscore lee of bracket x equal temp at line number, comma y equal temp at traffic count, comma type equal box, and then this percentage greater than percentage, then this adds another condition, layout of total equal interactive box plot by lane number of light vehicles, printing P. So we see interactive box plot by lane number of light vehicles. So these are the line numbers and these are the traffic counts, and we see that the mode, the median is highest for lane number 5, and the median is seems like lowest for lane number 2, and the maximum traffic count is for lane number 3. And then we let temp equal subset traffic, comma class weight equal heavy. Let's print the first few lines of this temp. So it looks like this. So you can see that let's run that. Class weight is heavy. Then unique of lane number. So unique of the lane number prints the unique values of the lane number, and we can see it's 2, 1, 3, 4, 5. Okay, so now we will use the interactive plot, box plot, to plot the data, the traffic count versus lane number. So table of lane number, that gives for lane number 1 there are 373 traffic counts, for lane number 2 there are 323 traffic counts, for lane number 3 there are 56 traffic counts, and lane number 4 there are 28 traffic counts, and lane number 5 there are 3 traffic counts. Box plot of x equal temp at lane number, comma y equal temp at traffic count, comma horizontal equal true. So we want the box plot to be horizontal, comma COL equal red. So we want the color to be red, comma main equal box plot of heavy vehicles traffic count versus lane number. So we want the title to be that. Let's run that. And we can see that the box plot is printed for 1, 2 and 1 and 2 lane number is quite heavy, but for 3, 4 and 5 is quite light. Then we do the interactive box plot. Let P equal plot underscore Lee of X equal temp at line number, Y equal temp at traffic count, comma, type equal box, comma, color equal red, and then we'll have percentage greater than percentage. We'll add another parameter, layout of title equal interactive box plot by lane number of heavy vehicles. Let's run that. And we see for lane number 1, so the median is highest for lane number 5 and it's lowest for seems like for lane number 3, but we 1 2. So the maximum traffic count is for lane number 1, and all these box plot, the range is seems like from nearly 100. The minimum is 100 for lane number so the minimum is 0 for lane number 1 2 3 4, but for lane number 5 the minimum seems to be about 210. Let's plot the scatter plot. Let's do the interactive scatter plot. Let P equal plot underscore Lee of X equal temp at lane number. So these are the heavy vehicles data. Y equal temp at traffic count. Type equals scatter. Size equal temp at flow direction. So these are the size of the bubbles and it is temp at flow direction. Color equal red. Then percentage greater than percentage, and it's another parameter, layout of title equal interactive scatter plot by lane number of heavy vehicles. Let's run that. So it prints. So lane number is on the horizontal axis, traffic count on the vertical axis, and the size of the bubbles is the flow direction. Let's use ggplot and let's add the facets. So let's import library ggplot2, and for plot we do ggplot of traffic, comma AES of X equal lane number, Y equal traffic count, comma color equal class weight. So color is class weight, and class weight is 2 options, heavy and light. Size of the bubbles is the square root of lane number plus geom underscore point, open and close bracket, plus facet underscore rep of this tilde and then space and then class weight. So what happens is that so line number is printed on the x-axis, y-axis has the traffic count, the color of the bubbles is class weight, so the red one is for heavy and the blue one is for light, and the size of the bubbles is square root of the lane number. And these black bubbles shows the square root of the lane number values.